Physics has long been our window into the universe, a discipline that has shaped our understanding of reality itself. From Newton's laws of motion, which explained the falling of an apple, to Einstein's theory of relativity, which redefined space and time, physics has been at the heart of humanity's quest for knowledge. These giants of science inspired generations, and their discoveries became the foundation for the modern world. But today, a new wave of skepticism is sweeping across the internet. Online forums, social media feeds, and even public protests are filled with voices claiming that modern theoretical physics is a sham, an elaborate game played by insiders, stifled by groupthink and institutional rot. These critics argue that the field has become disconnected from reality, more concerned with maintaining its own authority than with seeking the truth. They point to decades without major, paradigm-shifting breakthroughs as evidence. To them, this stagnation signals not the universe's inherent complexity, but a broken system, one that rewards conformity, chases funding, and punishes dissent. The narrative suggests that the pursuit of knowledge has been replaced by the pursuit of prestige and security. Social media amplifies these doubts, painting physicists as gatekeepers who fiercely protect outdated paradigms and shut out new ideas. The image of the lone genius, silenced by the establishment, has become a rallying cry for those who feel excluded from the conversation. Such stories resonate deeply with people who already mistrust elite institutions. For them, the struggles within physics become tales of corruption, cover-ups, and unlikely heroes fighting for truth. The debate is no longer just about equations or experiments, it's about who gets to decide what is real. Yet if public trust in physics erodes, we risk losing the very process that has driven our greatest discoveries. Collaboration, peer review, and a commitment to evidence are not just traditions, they are the engines of progress. Without them, science becomes vulnerable to misinformation and manipulation. Understanding and addressing this new skepticism is crucial. Only by engaging openly, explaining the challenges and uncertainties of science, and inviting the public into the process can we ensure that physics and all of science remains a trusted guide to the mysteries of our universe. At the center of this movement is Eric Weinstein, a non-academic with a massive online following. Weinstein claims to have solved physics' biggest puzzle with his theory of geometric unity, a theory of everything uniting gravity and quantum physics. He presents himself as the lone genius, bypassing traditional channels to appeal directly to the public. His narrative is compelling, a visionary outsider challenging a fearful establishment. Yet, for all the talk, Weinstein has never published a detailed, peer-reviewed paper for experts to scrutinize. In science, ideas must be testable, mathematically rigorous, and open to critique. Without this, geometric unity remains a story, not a scientific breakthrough. The lack of transparency has only deepened skepticism among physicists. The physics community has met Weinstein's claims with deep skepticism. Scientists like Sean Carroll stress that real progress requires open, detailed work, not just grand claims on podcasts. Carroll criticized Weinstein's incomplete, self-admitted, partially remembered notes as far from a real theory. For physicists, the issue isn't new ideas, but the lack of testable predictions and mathematical clarity. A valid theory must reproduce old results and make new, testable predictions. Geometric unity so far does neither. The scientific process demands show me the math, not faith in personalities. The burden of proof lies with the one making the claim. The debate over geometric unity often veers into conspiracy. Weinstein and followers claim powerful forces suppress revolutionary ideas, shifting the conversation from evidence to secret plots. He's even suggested peer review is a government tool for control, undermining trust in scientific scrutiny. These conspiracies blur the line between healthy skepticism and paranoia, making it hard for the public to separate fact from fiction. Linking scientific disputes to sensational narratives draws in audiences primed for distrust. As the debate devolves into drama, science becomes entertainment, not inquiry. This erodes public trust in all scientific authority. The controversy surrounding physics today is not just an isolated academic dispute. It's deeply entangled in a much larger political war on science and expertise. Across the world, but especially in the United States, science has become a battleground for competing ideologies. The authority of scientific institutions, once widely respected, is now frequently called into question. and the consequences ripple far beyond the laboratory. Particularly in right-wing circles, scientific organizations are often portrayed as elitist, out of touch, or even actively working against the interests of ordinary people. Media outlets and political figures amplify this message, framing scientists as members of a distant, unaccountable elite. This narrative has gained traction, fueling skepticism and even outright hostility towards scientific consensus. As a result, distrust in science has become a powerful force. It creates fertile ground for fringe theories and alternative explanations to flourish, making it easier for people to dismiss inconvenient or uncomfortable scientific findings. In this environment, conspiracy theories can spread rapidly, and the line between fact and opinion becomes increasingly blurred. The attacks on physics are just the latest chapter in a broader pattern, one that has already played out in debates over climate change, vaccines, and public health. In each case, experts are cast as gatekeepers with hidden agendas, accused of suppressing dissent and protecting their own interests rather than seeking the truth. This narrative of the lone truth-teller standing up against a corrupt or complacent system is deeply appealing to those already skeptical of mainstream institutions. It taps into a broader sense of alienation and mistrust, making it easy to see oneself as part of a righteous rebellion. In this context, the specifics of geometric unity, or any controversial scientific idea, matter less than the overarching story of rebellion against authority. The details become secondary to the emotional power of challenging the status quo. When science itself becomes a partisan issue, the very idea of objective reality is put up for debate. Facts are filtered through political lenses, and consensus becomes almost impossible to achieve. The result is a diminished authority for science in shaping our collective future, a future where evidence and expertise may no longer guide the decisions that affect us all. Political attacks on science have real, damaging consequences. Government funding is crucial for research, but anti-science rhetoric leads to budget cuts and canceled grants. Under the Trump administration, billions in research funding were slashed, stalling projects in climate, health, and beyond. Scientists, facing uncertainty, avoid risky, innovative work, slowing discovery. The loss of skilled workers from agencies like the CDC and NOAA means a loss of expertise that protects public health and safety. These aren't just numbers, they're lost opportunities and knowledge. When science is undermined, society pays the price. The chilling effect on research can last for generations. NASA, a symbol of scientific achievement, is not immune to political and budgetary battles. Downsizing and budget cuts have led to the loss of thousands of skilled employees, even as NASA faces ambitious goals like returning to the moon. Proposed cuts threaten to halve NASA's science budget, jeopardizing missions like the Mars sample return. Canceling such projects means dismantling teams and abandoning years of work. These missions require decades of investment and can't survive shifting political winds. The cost of lost exploration is a diminished future for science and discovery. Funding wars have real, lasting consequences for humanity's quest to understand the cosmos. In the age of social media, science communicators have become vital. Figures like Professor Dave use YouTube to debunk misinformation and explain complex topics to millions. They provide clarity on scientific debates, arming the public with facts and exposing logical fallacies. These communicators are a crucial counterweight to anti-establishment rhetoric, defending scientific integrity online. But the digital world is a double-edged sword. Algorithms can just as easily spread conspiracy as truth. The battle for public trust is fought in comment sections and feeds. The future of science may depend on communicators' ability to engage and educate in this chaotic environment. Maintaining trust requires constant vigilance and clear, accessible explanations. Science thrives on debate and challenge. Dissent is essential to progress. It is through questioning and challenging established ideas that we uncover new truths and push the boundaries of our understanding. However, this process must be grounded in a commitment to rigor and evidence. Without these, debate can devolve into mere opinion, losing its power to drive meaningful progress. We must welcome new ideas, but not at the expense of rigor and evidence. Every hypothesis must be tested, every result scrutinized. This is the bedrock of scientific integrity. New ideas are the lifeblood of science, but they must be subjected to the same rigorous standards as established theories. Only through this process can we ensure that our knowledge is reliable and robust. The scientific process, precision, testability, peer review, filters good ideas from bad. It is a meticulous and often painstaking journey, but it is this very process that safeguards the credibility of scientific discoveries. Peer review, in particular, acts as a critical checkpoint, ensuring that only the most rigorously tested ideas make it through. Challenges to physics should be met on the field of evidence, not just in the court of public opinion. Public opinion can be swayed by charisma and rhetoric, but scientific truth is determined by data and reproducibility. It is essential that we maintain this distinction to preserve the integrity of scientific discourse. Society must foster scientific literacy, teaching not just what we know, but how we know it. Understanding the scientific method empowers individuals to critically evaluate information and make informed decisions. This is particularly important in an age where misinformation can spread rapidly. By promoting scientific literacy, we equip society with the tools to discern fact from fiction. Understanding the process is our best defense against misinformation. When people comprehend how scientific knowledge is generated and validated, they are less likely to be misled by false claims. This understanding fosters a culture of critical thinking and skepticism, which are essential for a healthy, informed society. The quest to understand the universe unites us, but progress depends on honesty and shared commitment to truth. Collaboration across borders and disciplines is crucial, but it must be underpinned by a mutual respect for the scientific method and a dedication to uncovering the truth, no matter where it leads. Dismissing generations of scientific work as a sham betrays our collective journey. The advancements we enjoy today are built on the foundations laid by countless scientists over centuries. To disregard their contributions is to undermine the very essence of scientific progress. The future of science and our capacity for wonder depends on trust, rigor, and open inquiry. By embracing these principles, we ensure that science remains a beacon of knowledge and discovery, guiding us toward a brighter, more informed future.